Hi and welcome to part 1 on the video for inverse functions, chapter 4.6 in your textbook. The first couple of things that you need to know are just a bit of the background knowledge on the types of functions and relations. Remembering that one-to-one relations can be considered functions. They have one x value for every one y value that they have. These ones, we call them one-to-one, and this is the thing that we'll kind of be looking at a lot in inverse. You also have one-to-many relations. That means that they have one x value, but they have many y values attached to that one x value. Or they have more than one y value attached to that x value. And as you can see, there's a diagram there. Many-to-one relationships, they have, for the one y value, they actually have many x values. And then finally we have many-to-many relations. So that means that you get multiple x values for the multiple y values. Often circles are that kind of thing. Now I just do need to let you know that the first one here and the third one are actually both considered functions. Okay. Now the second one and the fourth one, the one-to-many and many-to-many, are not considered functions. So only the first one and the third one are considered functions. But then when we do the inverse, I guess what we'll find out is that some of the graphs that we want actually only need to be one-to-one, but we'll get to that a little bit later. But the first one and the third one are functions. Okay. All graphs, whether they're functions or relations, all graphs have inverses. But a function, one-to-one or many-to-one, has an inverse that is also a function only if the original function is one-to-one. Okay, I know that might be a little bit of a mouthful, but I guess another way of putting that is to say for the inverse graph to be a function, then the original graph has to be a one-to-one function. Now at this point you might want to just play that over and over and over again until you get it, or just put it on the back burner for a little bit and we'll come back to it a bit later. It sort of relates more when we're trying to restrict the graph so that the inverse is a function as well. Okay, so if it doesn't quite make sense, don't worry, we'll move on. Finding the inverse of a function or a relation can be done a couple of ways, and the first way I'll show you is using algebra. Now again, I assume that you've seen some of this sort of stuff before, but it will be good to rehash it anyway. So to find the inverse of a graph, we switch the x and the y variables and then solve for y again. So for example, y equals 2 log e of 3x, and I'm going to swap my x and y's to make it x equals 2 log e of 3y. And then I'm just going to rearrange so that I can get back to y equals, and hopefully you've followed everything that I've been able to do, and I've got y equals a third e to the x on 2. Now one of the things that I guess I need to tell you about, and I might make sure that I tell you about this in class, is that you often have to finalize your answer not as y equals, but in fact f negative 1 of x equals. Okay, it depends on the question, but often you would need to do this, not have y equals. Make sure I talk to you about that in class, so ask me next class. The next example that I've got is this one here. Again, I'm going to swap my x and y's and see what happens. So swap my x and y's, and eventually I get it so that the fraction's gone, or at least the y part of the fraction's gone, and then I get the square root, which means I've got a positive and a negative. So this graph will be looking like this, which looks a little bit ugly, but that's what it would look like if I was to use if I was to find the inverse using swapping the x and y values. Now the last one that I've got here is just a little bit tricky. I've got x squared plus 8x minus 4. I swap my x and y values. Now it's pretty tricky to get y by itself in this case, because I've got two y values. I need to somehow crunch those two y values down to one value. And just to kind of short circuit a little bit of your learning, like I will show you how to do this question, but no doubt it will come up at some point. What I'm going to do is I'm going to complete the square on just this little bit here, so that that's how I can get two y values down into one. Complete the square, and then I can just minus 16 and add all of those things to the other side, and then I get the square root of both sides, and I ended up getting this sort of thing here. Okay, so that's how to do using algebra. Hopefully you're able to do that with lots of questions. I guess the other way of finding out the inverse is to do it graphically. In this case, we actually swap the x and the y values. So essentially, we're kind of swapping the axis. If you have a look at what I'm trying to do over here, instead of having the x value over here, now the x value will be up the top. And instead of the y value being there, the y value is down the top, and the other two things swap over as well. So doing this, we obtain a reflection about the line y equals x. So, you know, this line y equals x used to be there, or it still is there, I guess. And what we've done is we've actually got a reflection over there, because that x value there is now up there, the y value is now down there. So there's a reflection on the line y equals x. So anything that crosses, any function or relation that crosses this line, those particular spots will stay put when we're trying to do an inverse, and you can have a look at that a little bit later. In fact, we'll have a look at that right now. So if I've got y equals x squared, and I draw the line y equals x, that means that the points that cross over the line y equals x, those 2 points will stay the same. And then what I need to do is I need to draw a mirror image based on that line there. So this part where it goes up like that, that would be this part over here. That's a mirror image there and there. There's a mirror image here and here, and these two little bits in here are mirrored images as well. Now, as you can see, this line, the original line y equals x squared, was a function, but when we got the inverse, this one here is not a function because it doesn't pass the vertical line test. Okay, so the original did pass the vertical line test, it is a function, but the new graph didn't pass the vertical line test, so that one is not a function at all. My next one that I've got is y equals e to the power of x. I draw that in my black. I've got my line here, and then so my line of y equals x, and then I draw a reflection about that y equals x line. So my y-intercept has now become my x-intercept. My y-asymptote has now become my x-asymptote. And as you can see, I've got, instead of having a y equals e to the x graph, I've now got a y equals log e to the x graph. And exponentials and logs are inverses of each other. Okay. Also, make sure you ask me about this BR to TL. I've got a sneaky way of finding out the inverse of a graph really quickly in an exam to save you heaps of time. So ask me about that in class, and I will help you out. Now, as we have swapped the x and the y values, it means that the domain and the range will also swap as well. Okay, so for example, I've got one here. If f of x equals x squared, my domain for this graph was all real numbers, but my range was real positive numbers and also 0 as well. When I get the inverse, I get the domain is real positive and 0, and my range is real numbers. But you can do that by looking at the graph, or you can just know that when we do the inverse, we actually swap the x's and y's, so therefore we swap the domains and the ranges. That will do for this video. In the next video, I will show you how to restrict the domain of a function so that we can get also an inverse function as well. So thanks for watching.